Okay, how do we identify similar polygons? Well, two things have to happen, okay? The first thing is they have to have all of the same angles. They have to have all of the same angles. And the second thing that has to happen between similar polygons is that they have to have proportional sides. All right, both need to be true. So I'm going to give you an example. I want you to draw this figure, and I wish you could do this cool trick that I'm going to do, but you can't, so just do your best to draw the figure, okay? So let's give yourself this polygon here. Does it look something like this? Okay. All right, so draw yourself that polygon, and here's what I'm going to do. Watch this. I'm going to lasso it, okay? And then I'm going to copy it over here, and then check this out. Now, what do I have now, right? Now I have similar polygons, don't I? I know, I wish I could buy you all tablets, right? One day we will get there, right? But I have similar polygons, right? And why do I have similar polygons? Well, let's start by naming these things, okay? Let's call this A, B, C, and D. And let's call this little guy over here, let's call that E, F, G, and then H, okay? So I said two things have to happen, right? They have to have the same angles. Well, angle A corresponds to angle E, and it's exactly the same angle. Angle B, which is different from angle A, so I'm going to use two rings, corresponds to angle F, and they're exactly the same angle. And I'm going to go all the way around the figure. Angle C corresponds to angle G. And then finally, angle D corresponds to angle H. So they all have the same angles. Would you agree?
Not mine.
Well, I mean, I know not yours because you have to draw it that way. But if you could do this, if you could see the similarities between the two. What? They have to have proportional sides. So what do I mean by having proportional sides? Here's what I mean. I mean that the length of AD has to be in proportion to EH. So here's how we write that. We say AD is in proportion to EH. And that proportion needs to stand for all of the sides. So my next side here, right, if I have AB, it has to be in proportion to EF. So AB has to be in proportion to EF. And then I'm going to work my way all the way around the figure. BC has to be in proportions to FG, and finally CD has to be in proportion to what? G. So polygon ABCD is now similar to polygon EFGH because all of the angles are the same and all of the sides are in proportion. You feeling pretty good about that so far? Can I answer any questions about that before we move on and see an example? No, we're good? Okay, let's go on to step box 2. Let's do an example together. Okay, let's do this. What we're going to do is we're going to list all of the similarities. All right, let's begin to list all of the similarities. Let's start with the angles. Can someone give me one angle that is the same? Yeah, so we can say angle B is congruent to angle E. What else can we say about the angles? Angle A is congruent to angle D. So this angle here is congruent to that angle there. And finally, what's the last angle we can say? Angle C is congruent to angle F. So this angle here is congruent to that angle there. All right, good. And then what about the sides, the length of the sides? Okay, we can say that AB is congruent to DE, and BC is congruent to EF. Hold on one second. And AC is congruent to DF. No, okay, sorry. I was saying AB is in proportion to DE, and that same proportion has to carry through for all of the sides. So sorry if I was saying it wrong. A little technical. So this thing right here that I'm putting a box around, there's a name for this thing, and it's called the similarity statement. So if they ask you for, please construct the similarity statement, this is the thing that they want. They want a list of all of the angles and all of the sides that are similar. So now we can finally say that since all of the angles are congruent and all of the sides are in proportion, we can say triangle ABC is similar to triangle DEF. Okay, so the question for you, for on the third one here with this example, are the figures similar? Yes or no, why or why not? So I want you to think about this and try and answer it on your own before we answer it as a class. Okay, so are they similar, yes or no? Why or more than that, right? So, Shanae, what did you say? So we're saying yes, okay? So far we know that, step one, we know all angles are congruent. Do we need that? Yes, we do need that. Okay, what's the second part that we need? Sierra, what'd you get? Proportional sides, yeah. So what are the sides that are in proportion? All of them. Can you give me an example of a side that's in proportion? Like, is AB in proportion to GH? Yeah, so AB is in proportion to EF. So if I write that out, I get 15 over 10. And that has to be the same as what? Keep going all the way around the figure. 6 over 4, that has to be the same as what? 9 over 6, which is the same as what? 12 over 8. Now, let's simplify each one of those fractions. How do I simplify 15 over 10? 3 halves, right? Do you agree? What about 6/4? Is that the same thing? 3 halves. What about 9/6? Is that the same thing? 3 halves, and then finally 3 halves. So, if all of these are equivalent fractions, do I have enough time to say that the figures are similar? Yes, I do. So I can say that A, B, C, D is now similar to E, F, G, and H because all the sides are the same and all of the all the angles are the same and all the sides are in proportion of 3. 4 and the side is 9. Okay, so you try. The question is, are they similar? Yes, no, why, or why not? So I have them drawn not in the same direction. So see if you can figure out if they are similar. Rhett says no, because the sides aren't in proportion. Can you give me an example of which two sides are not in proportion?
I got
LM and has to be in proportion to what? RQ. Do we agree? Is that the right setup for that? If I switch that around, is that the same setup? Yeah, it's the same setup, right? So is 10.5 over 9 in correspondence or in proportion to what? 12 and 4, right? 12 and 4. So do we agree with that? Is that true? Is the 12 and the 4 in the right spot? Yeah, do we agree with that? Yeah, okay, so since the 12 and then the 4 there. So since these are not in proportion to each other, these objects are not similar. Did everybody get that? Until I show you in the context, okay? So theorem 8.1 says that if two polygons are similar, then the perimeters are in the same proportion as the sides. That's what that says, okay? So here's an example, okay? If I give these two polygons that I'm calling similar side lengths, let's call this one 6, let's call this one 8, and let's call this one 10. Then this is going to be 3, 4, and then 5, right? So the bigger one is in the ratio of 2 to 1. You guys agree with that? Yeah. It's in 2 to 1. So let me show you what I mean by the perimeter, right? If I add up the perimeter of the big one, 6 plus 8 plus 10, how much is all of that? 6 plus 8 plus 10. Okay, how much does it equal? 24. And if I add up all the perimeters of the smaller one, 3, 4, and 5, how much is that? 3 plus 4 plus 5. Check it out. It's still in proportion of 2 to 1. That's what that's saying. It's the same proportion as taking this side over that side. It's still in the same proportion of 2 to 1. So the perimeters are still proportional to all of the sums, or to all of the individual side lengths. Does that make sense? I'm doing a terrible job of explaining that. But do you guys get it? The visual helps, doesn't it? It helps me, right? Okay. Okay, actually, there's only one more box too, because the last one is we get to watch something. So I'm going to show you. Yeah. Right, so I've got these two figures here, right? So the last thing is we're going to use the fact that the two polygons are similar to solve a proportion and solve for x. So if I know ahead of time that these two figures are similar, then I can set up a proportion that's pretty straightforward. I can say that 10 is to x as 15 is to 6, and then I can write that out. So 10 is to x as 15 is to 6, and then I can easily solve for the proportion that x is, right? Okay, so 15x has to be 60. So if I divide both sides by 15, what does x have to be? 4. Yeah, 4. There we go. So if I plug that into 4, so x has to be 4 to keep my proportions similar, okay? So you'll be doing figures with those, so I wanted to give one of those out there. Is that pretty straightforward? All right, so here you go. All right, okay, so you see these two pictures I have here? What do these have? No, they're TVs, right? Okay. There are two different types of TVs. Do you know which different types of TVs there are? They are? What's the one on the left called? Anybody know what it's called? The one on the left? Nah, an older TV. One on the left. What's... No. It's a type of signal that it picks up. No, this is an analog. That's an analog signal. What's the kind on the right? Which would be what type of signal? No, digital. Digital signal. Okay. So do you know something about whenever you go to like Best Buy or whenever you go to Target or you go to the TV section, the electronics section, they tell you, or Costco, they tell you that the TV is a 27-inch TV. So what are they referring to with a 27-inch TV? Why do they only give you one dimension? What is that dimension? It's not across, no. Not the width, no. It's the diagonal. That's exactly right. So they give you the diagonal. So if I told you that was 27 inches, okay, and I compared that to this diagonal that was 27 inches, would you say that those are similar TVs? Yes or no? Yes? Why do you say they're similar? Are the screens the same size? No, they're not the same size, right? Okay, do you know that in analog TVs or older TVs, the ratio was 4 to 3? What's the ratio in digital TVs, most digital TVs these days? No? You guys don't know this, huh? It's actually 16 to 9. Okay, there's a different ratio, aspect ratio of 16 to 9 versus 4 to 3. So, are these now in proportion? How can you tell? Are these similar TVs? Are they still similar? What do you think? You still say yes. Okay. Well, in order for it to be similar, two things have to happen. What's the first thing that has to happen? All the angles have to be the same. So that angle and that angle, same. Do we agree with that? Okay, good. And the sides have to be in proportion. So I need to check. Is 16 over 4 the same thing as 9 over 3? No. Yes or no? No. Let's simplify this fraction. 16 over 4 is how much? 4 to 1. Is that the same thing as 3 to 1? No, these TVs are not similar because they do not have the same ratio in proportions, right? Most TVs nowadays have a 16 to 9 aspect ratio, whereas older TVs, such as the one on the left, used to have a 4 to 3 aspect ratio, so they're not similar. Okay.